All right, so next section we're going to look at is we're going to jump to chapter 2. It's on angles and their measures. So in this section we look at basically what an angle is, and then we look at how we can measure it. So there's two main ways we measure angles. A lot of people are familiar with degrees, but there's also another unit. Does anybody know the other way you can measure an angle besides using degrees? Okay, well that's why we're going to take a look at what that is today. So before we even talk about what an angle is, we're just going to talk about what makes up an angle. So an angle is made up of two rays. Okay, so a ray is basically a portion of a line. It just goes in one direction. Okay, so it's got a starting point you call the vertex, and it goes out in just one direction. Think of it kind of like the beam of a flashlight. You turn it on, one direction. It doesn't go the other way. So now if we take two rays, okay, we just draw two rays. So there's one. There's two. And separately, the red and the black ray are not an angle. But when I combine them, put them together so that their starting points line up, okay, so that the vertices are right on top of each other, now I've created an angle. So if you take two rays, put the vertices together, that's an angle. And there's another example right there. Now, technically, there's two angles there. Okay, there's the one on the inside, but then there's also the one on the outside. Generally, we're talking about the one on the inside. Okay, so kind of a short way you could travel between the two angles, or the two rays. So when we have the two rays, those form the sides of the angle, and one of them is called the initial side, and one of them is the terminal side. So if I was going to label in this diagram, this is the initial, this is the terminal. And I'll tell you in a second how you figure out which one is initial and which one is terminal. And there's another picture right there. Okay, so the way you figure it out is basically you rotate counterclockwise. So you start at one side, and as you rotate counterclockwise, that's the terminal side. All right, so if I drew something like this is initial. And then as I rotate around, I end up at the terminal. Okay, any questions on that? Usually the initial side we always put horizontal, so that's going to make it easier to figure it out. When we draw an angle, that's not normally how we do it. We always like one of the sides to be horizontal, and that's the initial. Right, so when we start measuring angles, I've kind of been using the words counterclockwise, and I haven't really used clockwise yet, but those are the two directions you can measure an angle in. And depending which way you measure, that's going to control whether you have a positive or a negative angle. All right, so if you're rotating counterclockwise, okay, that would be considered a positive angle. And I'll show you a picture in a second. I have a program I can kind of draw different angles in, and it'll show you the measurement. Okay. So if you rotate the other way, then it's clockwise. Or if you rotate the other way, clockwise, it's negative. Generally, what kind of angles do you think we like to deal with more? Like it's easier to work with, positive or negative?
Positive.
Positive, yeah. If we can keep the angles positive, I don't know, it's just easier. Most people find it easier to work with positive numbers than negative numbers. Right? So here's an example where I can't move the initial side. The initial side is stuck on the x-axis, but I can put the terminal side, okay, wherever I want. So now this is an angle of 139 degrees, and the rotation I did to get there was counterclockwise. That's why it's positive. Okay. If I go the other way, now you can see what happens. I start getting negative angles. Okay. Initial side didn't move, but the terminal side went clockwise. So this number on the top is degrees. This number on the bottom, that's the other way to measure an angle, and that's what we're going to talk about in a little bit. If you notice, there's always two ways to get to the same spot. So if you wanted to get to 90, that's exactly the same as negative 270. Okay? It's the same, the terminal side ends up at the same spot, pointing straight up on the y-axis. All right, so given the choice of working with negative 270 or 90, I would probably want to work with the 90 because trig-wise, 90 and negative 270 are the same number. Okay, usually if you're doing trig. Any questions on that idea? Yeah.
How are we going to see on paper which way it's going?
If you were going to draw it, I'm not going to be picky about it, but you'd have to put a little arrow on that red thing, and then you'd be able to tell.
So when we did a test and it has a picture of an angle, there's going to be an arrow so we know if it's...
If I had something like that, yeah, you won't have anything exactly like that. But if you did, yep, I'd put an arrow so you know which way it's going.
Okay.
Yep. And then if you wanted to represent drawing an angle that's even more than one revolution, you can do that too. So then you have to make it more like a spiral. So now I can see that it went around more than once. Again, you're not really going to have to sketch anything like that, but if you wanted to, that's how you do it. You just make a spiral how many times you go around. All right. So I said to you that usually when we sketch an angle, we're going to draw it so the initial side is always horizontal. Okay? That's exactly what this program does. I can never move the initial side. And if you never move the initial side, then what you're doing is drawing an angle in what's called standard position. So for an angle to be in standard position, there has to be two things. One, the vertex of the angle is at the origin. All the angles that I just drew in that program all had their vertex at the origin. I cannot move that vertex right there. It always stays right at the origin. So that's the first thing. And the second thing is the initial side always has to be on the positive x-axis. So what this does is it gives us a way that if I told you to draw or roughly sketch a 45-degree angle in standard position, then everybody's 45-degree angle should pretty much look the same if we're all drawing it in standard position. Okay. If we didn't use standard position, then some people might draw their angle like this. They might put the initial side going up at an angle, or like this one. But we want to stick to always drawing angles that look like that. Initial side is always horizontal. Okay, there's just another angle in standard position. What if I did that? Is that angle in standard position?
No.
No. Why not? The initial side is on the positive x-axis.
It's not the origin.
The vertex is not at the origin. Okay, so that's no good. What if I did something like this? Is that standard position?
No.
No. The vertex is at the origin, and terminal side is on the y-axis, but doesn't say anything here about terminal side. It's the initial side. It has to be on the x-axis. Okay? So it has to look just like that. So any questions on what it means to draw an angle in standard position? Yes? Sean?
Or if it's the other way around, so like if the terminal is like rotated around.
So if the terminal was...
So like it was still on the x-axis, but instead of pointing up, it's pointing down.
Not like that?
No, like in
It's on the negative side. I think he means like flip.
yeah.
So if this side was like this?
No, I mean yeah, I'm at like it's completely rotated and then I'm at 180.
Rotate that 180 degrees? Okay.
But on the origin, like yeah.
So what's your question about it?
Is that still technically or no?
What do you guys think? Is that standard position?
No.
Nope. Because the initial side is not on the positive x-axis.
Oh, okay.
It's on the negative x-axis now. Yep. All right, so degrees, one way we can measure an angle. Radians is the other way. So we'll talk a little bit about what radians are, and then kind of the big idea is how do we convert between the two? Degrees to radians, radians to degrees. So this is the question we want to answer. Okay, we know that in one revolution it's 360 degrees. But I want to figure out in one revolution how many radians. Okay, if I can answer what goes in the question mark, then I'll have a conversion between degrees and radians. Okay, and it's kind of like if I said to you like 12 feet, or let's do it this way, 12 inches equals a certain amount of feet. Okay, so what's the answer there? 12 inches is 1 foot. So now that I've answered the question mark, I could set up a proportion and say, well, in 12 inches, there's 1 foot. So then if you said to me, well, how about, 60 inches? Well, inches on the top, feet on the bottom, inches on the top, feet on the bottom. And all I have to do is solve by cross multiplying. But the key is I had to know this. Okay, you have to know something to start with, this fact, and then you can figure out something else. Now, because I picked a 12 and a 1, does that limit what number I could put here and here? No. You could give me any number of inches or any number of feet. Just because I picked a 12 and a 1 doesn't control what numbers I can put on the other side. I can use anything I want. In fact, could I have done something like this? Could I have used that fact instead? Yeah, you could use any fact that you know is true. We usually use a fact that has a 1 in it, because that's the easiest. Okay. So we'll come back to that idea of getting a 1. But right now, we've got 360 degrees equals, and then we got to figure out how many radians. So first thing I'm going to do is just draw a diagram and try to get you to visualize what a radian looks like. Well, if you look at the word radian and you think about circles, does the word radian kind of look like any other word having to do with circles?
Radius.
Radius. You just change a couple letters on the end and it turns into radius. And a radian has a lot to do with a radius. Okay? In fact, I'm going to use that in the definition. So what I've drawn here is a circle. Inside the circle, I have an angle in black. The two rays of the angle come out from the center. And the first ray hits the edge of the circle there. And the second ray hits the edge of the circle right there. Between those 2 points that I just marked, I can draw that arc in red. And that's all I've done so far. Any questions on that? Okay. So what I've labeled right there, and I'm going to add some back in a second, but I'm just going to erase it for now. Those two lines or two rays in black are the radius of the circle. Well, what happens is if you draw that angle just right, so that that arc in red is exactly the same length as the radius, you've just drawn a picture of 1 radian. So if you took a piece of string, measured the radius, and then that piece of string was exactly the same as that red arc, then you have a picture of exactly 1 radian. Okay, so if the length of the arc in red is exactly the same as the radius in black, and the angle in the picture is 1 radian. Still doesn't really answer the question about how many degrees are in a radian. It just gives you something to picture kind of in your head of what a radian would look like. And that's pretty accurate. I would say that's pretty much to scale.
Wait, is this gonna be like a test question? How many radians or something?
You're definitely going to have to know how many radians in degrees. Yep. You're going to have to convert between the two. All right. So now, I'm going to give you a fact that you just have to trust me is true. Because to convert between degrees and radians, you have to know something. Okay? You can't start with nothing. So I got to give you something to start with. And when I give you that, I think we'll be able to figure out how many degrees are in a radian or vice versa. All right, so the first part of the fact says that if you measure an angle in radians, it's going to come out the same as something else. Okay. Measuring an angle in radians is equal to the length of the arc. And the arc is what I drew in red. But not just any arc on any circle. It has to be on what's called a unit circle. Okay, so this is going to be our starting fact. Kind of like in 1 foot there's 12 inches. You can use that to figure out other conversions. Well, this is going to help us to figure out the conversion we want to know. And if you're saying, well, why is it true? It's kind of like saying, well, why in 1 foot is there 12 inches? It's kind of the way it's defined. It's the way it is. All right. First, let's start with the word unit circle. Does anybody know what a unit circle is? It's a circle, but it has a special radius. Anyone have a guess what the radius might be on a unit circle? Well, what would be a nice number to work with? Very easy number.
1.
1, right? Very easy number to work with. So a unit circle is just a circle where the radius is equal to 1. That's all it is. All right, so let's see if we can kind of visualize what that fact means. All right, let's say I draw a circle. That's exactly 1 foot, okay, for the radius. It might not be exactly to scale, but we'll just pretend. So that's exactly 1 foot. Okay, and then that's the initial side. I'm going to put the terminal side right there. I want to know how big that angle is in radians. Okay, that's the question. Well, this is saying that if you want to measure the angle in radians, it's exactly the same as the length of the arc, okay, on a unit circle. And that's what I drew. 1 foot is a unit circle. So if I had a piece of string, and I put a piece of string right there, and I measure that piece of string, put it on there, then put it on a ruler, and see how long it is, let's say it comes out to, I don't know, let's say it comes out to like 0.75 feet. Okay, so that'd be like 9 inches. Okay, so 3/4 of a foot, 0.75 feet. If that measures 0.75 feet, then that angle is 0.75 radians. If that measured 1.5 feet, that arc in black, if it comes out to 1.5 feet, then that angle would be 1.5 radians. So any question on that idea? The length of the arc and the size of the angle are always the same on a unit circle. Yeah?
So is that angle 1 radian?
If this arc was 1 foot, yes.
What's that arc?
It could be anything.
Oh, we haven't got it yet?
Yeah, we didn't measure it. If the arc is 1.5 feet, the angle is 1.5 radians. If the arc is 3 feet, that's 3 radians. Whatever it is, they would match. They would
I just wasn't sure if you got it yet.
No, it's just kind of generic. Okay.
Wait, so that's the only way to solve it is with a piece of string? You gotta measure it?
No, you don't have to use a piece of string. I'm just kind of saying if you did that, that's how you could do it. But no, there's much more mathematical ways besides using a piece of string.
Alright.
Yeah.
That's
just kind of a visual. Some people are like, well, how do you measure a curve? Like you can't use a ruler. Well, you use a piece of string. Just trying to make it simple. So what I need to do is figure out this. 360 degrees. How much of a circle is 360 degrees? It's the whole thing. So now, if we can figure out the size of the whole thing, okay, what I just traced in black, we normally don't even call that an arc anymore because it's an arc so big that it goes all the way around the circle. What do we call that?
A unit circle?
What about the circle? This line in black is the
Circumference?
perimeter of it, which is the circumference, exactly. So if we can figure out what the circumference is of a unit circle, the circumference is going to be exactly the same as the angle in radians. Remember, we're trying to figure out what 360 degrees is. So we just have to find the circumference that goes all the way around of a unit circle, and that's how many radians it would take to go all the way around. So what's the formula for the circumference of a circle? Well, Eric, do you have a guess start us off a little bit?
I assume it has something to do with pi.
Yep, it's got pi in it. Yep.
Pi times radius squared.
So you're thinking of area. We're going to use that formula tomorrow, though, so keep that in mind for 24 hours later. But we're going to come back to that.
1/2 pi times r.
So I like the pi and the r, but the number in front is not a half. 2. Yes. That's the side, that's the formula for circumference. Now, we're working with a unit circle, so we know the radius. What's the radius of a unit circle? 2 pi. Well, what's the radius first? 1. The radius is 1. So the circumference of a unit circle is 2 pi. Now, reading what it says up above, the arc, or you can call it circumference, the circumference is equal to what? What does it say? So the length of the circumference is equal to the size of the angle in radians. So the arc is 2 pi units, which is exactly the same as the angle in radians, which is also 2 pi radians. So now we know to go all the way around a circle, it's 2 pi radians. So that answers that question based on the fact I gave you about a unit circle. So now we've got our fact that's kind of like 1 foot equals 12 inches. 360 degrees equals 2 pi radians. Now we can set up a formula to convert between the two. So let's write that down. So 360 degrees equals, I'm just copying down this part up at the top so I don't have to keep scrolling up and down. 2 pi radians. What can we divide both sides by to kind of make that a little smaller?
2.
Yeah, we can divide both sides by 2. So if 360 degrees is 2 pi radians, 180 degrees is pi radians. But even now, what number did I say we usually like to have in a conversion?
1.
1. Okay. If you were going to ask me how do you convert minutes to hours, I would say, 60 minutes in 1 hour. I wouldn't say 180 minutes in 3 hours. It's true, but we always try to make it as simple as we can. So let's start. All right, let's start by getting a 1 on this side. What would I have to divide each side by to make the left-hand side a 1?
180.
Divided by 180. I'm just going to put a box around that for now. And I'm going to divide by 180. And I'm going to divide by 180. 180 divided by 180 is 1. But what's the unit that's still on the left-hand side?
Degrees.
Degrees. That didn't cancel. The degree symbol is still sitting right there. So it's 1 degree equals pi over 180 radians. And that's a formula that will allow us to convert from degrees to radians. So let's say, well, you're like, well, how would I use that? Well, let's say I wanted to know 3 degrees. 3 degrees equals how many radians? Just take this equation, multiply by 3, multiply by 3. Now you've got a formula that says 3 degrees equals that many radians. You could just type that in on a calculator and get the answer. If I wanted to know 7 degrees, times 7, times 7.
You would only times the top by 7?
Yeah, because remember, think of 7 as 7 over 1, right?
Wait, so that's the formula you use for every circle?
That's the formula you use to convert degrees to radians.
Yeah.
For everything. Yep, every angle. What if I wanted to know how many degrees in,
I don't even remember how it
all
goes.
right, how many radians in 12 degrees? What would I do to that equation?
Times by 12.
Times both sides by 12. Now the left side says 12 degrees equals, and you can reduce the right-hand side, but if you're just typing it in on a calculator, it would reduce it for you. So the key is, anytime you want to change degrees to radians, you multiply by pi, and you end up dividing by 180. Those are the 2 steps. Anytime you want to change degrees to radians, you take the angle that you're trying to convert, 12, 6, 5, whatever it is, multiply the angle by pi, and then divide by 180. Okay, I'm going to get rid of the 12 because that's a specific number. You can do it with any number you want. All right, so that gives us a way to change degrees to radians, but we also want to have a way to go back, change radians to degrees. For that, we're going to go back to this box in black. Okay. To get the box below it in red, what did I do on both sides?
Divided by 180.
I divided by 180 to get a 1 on the left. Well, let's take the same thing, except this time I want to get a 1 on the right. So what would I do to make that happen? Yep.
Divided by pi.
Divide by pi. Pi, pi. All right, so now the pi's cancel. Pi divided by pi is 1. what unit is still on the right side?
Radians.
Radians. So 1 radian equals 180 over pi, and the degree symbol is right there. So that tells you how many degrees in 1 radian. So if you wanted to actually figure it out, 180 divided by pi is about 57, a little over 57 degrees in 1 radian. What if I wanted to know how many degrees in 3 radians? What would I do to that equation, or that box in red?
Divide that and times it by 3.
We just times both sides by 3. Times 3, times 3. Now if you do the calculation out on the left, it'll tell you how many degrees in 3 radians.
Wait,
What-
so you do 180 times 3, then divide it by pi.
Yep, it's going to be just the opposite. It's going to be divided by pi this time. Yep. So if you wanted to convert 7 radians is how many degrees? You would take 7 times 180 and divide by pi. Okay, so to convert from radians to degrees, it still involves pi and 180, but it's the opposite. This time pi is in the bottom, and the 180 is in the top. So if you said 12 radians, how many degrees is it? I'd say, okay, multiply 12 by 180, and then divide by pi. And now those two steps are kind of similar. One of them you multiply by 180 and divide by pi. The other one, it's multiply by pi and divide by 180. So in a second, I'm going to show you a way to kind of keep track of how you remember to do which one when. The only thing you have to remember is when you see 180, I want you to think degrees. Okay, so connect those two things in your head. 180 degrees. 180 degrees. When you see pi, I want you to think radians. Pi, radians. Pi, radians. Just connect those two numbers with those two labels. And if you do that, you don't even really have to remember these two steps or those two steps. Just pi, radians, 180 degrees. Okay, so let's look at an example. So this one says to convert, the next few examples are all convert to radians. So I know I'm going to multiply by either pi over 180 or 180 over pi. It's always one of those two. My goal here is to get radians. So when I'm done the problem, I don't want to have degrees anymore. Think of 60, if this were a fraction, you can always put it over 1. Degrees is in the top of this fraction. Where would degrees have to go to cancel out the degrees in the top? Where would it go on the right? Yep, it would go in the bottom. So if degrees is going to go in the bottom, that means radians has to go in the top. Now we just have to remember what number goes with radians and what number goes with degrees. Okay, so when you see radians, what number do you always think of? Pi. And when you see degrees, 180. It's exactly the steps we just did, or we just wrote, right here. Multiply by pi, divide by 180. We're changing to radians. But I always think of it as, okay, if I can put the unit in the bottom that I want to cancel, that'll automatically tell me which one goes in the bottom, pi or the 180. All right, so now we just multiply it out. We can reduce 60 and 180. What's 60 and 180 divisible by? 3? Yep, even bigger.
60.
60. Yeah, we can just go right to the biggest. 60 goes once. 60 goes into 180 3 times. And our final answer is 1 times pi divided by 1 times 3. And that's how you write the final answer. some people look at that, what might they think I forgot to write? But I didn't.
Degrees.
RAD, right? Radians. I didn't forget to write it. If you look in your book and any other textbook, you'll never see RAD written. Okay, they just don't write it. So if you're dealing with an angle and you don't see the little circle above it, then it's radians. If you see the little circle, then it's degrees. But you're not going to see the label RAD in the book or on the test. Okay, I put it there just so you can kind of get used to it, but you should get used to not writing it in the final answer. If it helps you, you can write it. I wouldn't take off any points, but you don't ever see it written. Okay, questions on that? And I don't know if you noticed when I was using this program, but certain angles all of a sudden switch to having like a pi symbol in them. There's one right there, pi over 4. And we just did 60. If I can get it right on 60. No. Close enough. If I could get it right on 60, it would say pi over 3, which is exactly what we just figured out. Okay, any questions on it? All right, let's try 150. So same directions, change to radians. Right. Okay, we're trying to cancel out degrees because we want to get radians. So where am I going to put degrees? Where is degrees going to go in this fraction?
On the bottom.
Yep, in the bottom. And that means what unit's going to go in the top? Christian? Radians. If you want to write it, you can. I'll do it one more time just to kind of get used to it. Corey, the number that we always put with degrees?
180.
Yep. 180 always goes with degrees when we're converting. And Skylar, the number we put with pi? Yeah. Sorry. The number we put with radians is pi. Very good. I like to reduce before I do it. So 150 and 180, both divisible by
30.
You could do 10, yep, and you can go even bigger, you can go 30. 30 goes into 150. How many?
5.
And 180?
6.
6. So what's my final answer?
5 pi divided by 2.
Perfect. 5 pi divided by 6. And if you're like, well, how come we're not changing it to a decimal? You don't have to. Unless they say to round it to 2 decimals or 3 decimals, you leave it just like that. You don't use decimals unless they say to. Okay. Any questions on that? All right, let's try a negative. Okay, negative doesn't change how you do it. Do it just like it was 45 degrees. But then when you're done, throw a negative in front of the whole thing. So, Oscar, can you tell me just what you multiplied by?
What do you?
Like to convert degrees to radians, what did you put in this fraction?
Like negative 45.
Yep.
I just multiplied it by. You want me to set it up for you?
Yeah.
Alright.
Yep.
I said pi over 180.
Perfect. Pi, radians, RAD, pretend it's there, it's invisible, over 180. And now when you reduce it, you're done. Okay, so Eric, did you find a number that goes into both of those?
I did 9.
Yep, you could do 9. And what did you get when you did 9?
Negative 5.
Yep, and
20.
20. And now 5 and 20 can also be reduced by 5.
Yep.
So if we can reduce by 9 and then 5, 9 times 5 is 45. Did anybody reduce by 45? Right off the bat? Yep. That's fine, or you can do it this way too. Right, so now I write my final answer. Michael, what's my final answer there?
Negative pi over 4.
That's it. Perfect. Negative pi over 4. What's the difference with a negative angle versus a positive angle?
It'll go counterclockwise.
Yeah, it's just the direction. So the positive angles, those are going that way, counterclockwise. Negative angle, the terminal side is swinging clockwise. That's kind of the same, so let's do one that's a little different. Let's do 107. And this one I'll say round to 2 decimal places.
Wait, so this one is printed into a decimal?
Yep, this one you'd have to use a calculator for. We'll set it up, but then we'll type it in. So we still set it up exactly the same way we would do any problem. Generally, if the number is not a multiple of 30 or 45, they're going to have you round it. Like 107, 106.2. If you have numbers like that, they're going to have you round it. Nice numbers like 90, 45, 150, 180. Anything that's a multiple of a 30 or a 45, they'll probably have you leave it exact. Okay, but there'll always be directions on the test. Okay, set that up. Derek, can you tell me what I multiply by here?
Pi over 180.
Yep. Degrees cancels. And now, since we're going to round it off, even if this did reduce, don't even bother. Just type the whole thing in and see what you get. So 107 times pi divided by 180. Okay, order of operations, the calculator will handle that fine.
You know, for pi, is it good if we just use 3.14?
You want to use the pi button. I'll show you what happens on the next problem we do if you don't. Okay, might mess up the accuracy a little bit. Okay, so that comes out to 1.87. Remember, not 1.86. Okay, so if it was a multiple choice question and one of the answers was 1.86 and one was 1.87, 1.86 is wrong. That's not properly rounded. Okay. Any questions on that? Yeah.
Would that be 1.87 pi?
No, because I multiplied, the pi was part of it. It did 107 times
My calculator knows that pi.
3.145, all the decimals divided by 180. Okay, if you don't have a pi button, you could use one of mine. They all have a pi button on them. Okay. Or, if you type pi into like 10 decimal places, it's probably accurate enough. But don't just type in like 3.1 for pi. That's not.
3.14?
I'll let you use one of mine.
Alright.
Yeah. Okay. Okay. Questions on changing degrees to radians? Okay. So let's finish up by trying the other way. So now we'll change radians to degrees. So on the first one, I'll write RAD just to kind of get used to it. But then after that, I'm going to stop writing it. Alright, so we're trying to get to degrees, so we want radians gone. So anybody tell me where radians would have to go to cancel out? Yep, it's good. It's going to go on the bottom. If radians is on the bottom, degrees is on the top. So Joe, what number are we going to put on the top?
180.
Yep, 180. And Kate, what number on the bottom? Pi. Now, before I multiply, Christian, what cancels out there?
Radians.
Radians cancels. Anything else? Pi cancels. So all I'm left with is 180 divided by 6. And don't forget the degree symbol. You have to put the degree symbol, because that's important. If you didn't put the degree symbol, it would be radians. So what's 180 degrees divided by 6?
30 degrees.
30 degrees. Yep. Any questions on that? right? I got a bunch of them, but we'll just try a couple. Let's practice without having the words RAD. Okay, so in your head, you just want to remember, okay, it's 3 pi, radians is on the top, just like it was here. So Corey, what am I going to multiply by here?
On top, you're gonna have degrees. So,
Yeah.
180.
So 180, got to put that degree symbol.
And then pi.
And do I have to write RAD?
Yeah.
No. So now in our head, it's invisible. Radians cancels. And Sam, what else cancels?
Pi.
Yeah, very good. Pi cancels. And we can reduce. 2 goes into 180 90 times. Okay, so Oscar, what's my final answer?
210.
Careful. 3 times 9 gives me
270.
27, 270. And do I need a degree symbol on it?
Yeah.
Yes, because I had one right there. Okay, 270 degrees. All right, that's just a negative. It's kind of the same thing. Let's do this one. 3 radians, and we'll round to 2 decimals. On this one, I'll show you what happens if you use the pi button versus 3.14. And again, you gotta get used to seeing it just like that.
Round 2.
Round to 2, 2, 2. That's no business. Right, so Justin, what am I gonna multiply by here?
About 180.
Multiply by 180, okay. And divide by
Pi.
pi. Right. So now we've got 3 times 180. 3 times 18 is 54. So that's 540 divided by pi.
What? Wait, where's the 4th number? Oh.
You can always put it over 1 if you really want to. But 3 times 180, that gives me 540. Well, you could just type it in, but that's what it is. Divided by pi. So on mine, I press second. So if you can't find the pi button, I'll help you after. And you get 171.89 degrees. Now, let's say instead of pi, the pi button, you use 3.14. So 540 divided by 3.14. I get 171.97. So 0.88 and 0.97. It's kind of off a little bit. It's not like you got 0.88 and 0.89. Well, that'd be pretty close. But in this case, it's not really that close. Okay. So make sure you use the pi button. Yes?
So for that, if you can say round to decimal places, can we use pi and like degrees?
Leave the final answer as like 540 over pi degrees.
Yeah.
Yep, that's the exact answer. And there's no other way to write the exact answer. But most of the time, if it comes out messy like that with pi, they're going to have you write it as a decimal. The only reason they didn't have you do it here, here, or here is because the pi always canceled. But if you don't have pi in the original problem, like we did, it's not going to cancel. Okay, so any questions on converting between radians and degrees? All right, so the homework tonight, it's page 99, and it's 36 to 68 even. Okay, so you've got a little under 20 minutes. Okay, So please use the time to get started. If you have any questions, you can ask me. If you're making a reference sheet for the test, you could start putting some of these formulas on it. But just please work on something. Yes?
Wait, do you have us read these out? Like, can we just like start our homework where we leave on our notes?
I'm not going to collect your homework, so you could put it right in your notebook. Yep, that's fine.
What are syllabus?
Yes, if you have the syllabus sheet signed, I will also I will collect that.